Namaste students, welcome back to Rama Teaches You. Today we are going to do the first video. The first video on chemical bonding and molecular structures, chapter number 4, class 11th chemistry. Okay, so this is going to be a full English video. So let's start. Now, we have studied in earlier chapters that matter is made up of atoms and also that atoms other than noble gases do not exist independently under normal conditions. So they usually form bonds with each other. Right? They cannot stay isolated because they're not stable in nature. Atoms, they want to be as much stable as possible. However, a group of atoms that have a tendency to combine with each other and behave like a single species are called molecules. These molecules have the ability to exist independently on their own. Okay, perhaps a question may arise as to why do certain atoms one stable and do not react while other atoms are unstable and react. So obviously there must be some force which holds the constituent atoms in a molecule together. Such forces are known as chemical bonds. Inside the molecule, the one atom is being held together by the other atom via a chemical bond. Okay, now general introduction to bonding, ionic and covalent bonds. It is defined as the force of attraction which holds various constituent atoms, ions together in different species. So a chemical bond could be both an ionic bond or a covalent bond. The chemical bond, the main job of the chemical bond is to hold the atoms together. That's it. That's the overall job of a chemical bond. Okay, the chemical bond can be classified into various categories like the ionic bond, the covalent bond, the coordinate bond, metallic bond, hydrogen bond, and the van der Waals forces. Several theories have been put forward from time to time to explain the concept of chemical bonding. Some of these theories are Cossel-Lewis approach, valence shell electron pair repulsion theory, the valence band theory, and the molecule orbital theory. So we are going to understand each and every single part of this, the first, the second, and the third, and the fourth. Okay, all of these are pretty much interesting. Now, the Cossel-Lewis approach to chemical bonding. In 1916, Cossel and Lewis succeeded independently to give first successful explanation about the cause of combination between atoms, which was based upon the understanding of the electronic configuration of noble gases. They believed that if an atom can attain the noble gas configuration, because why did they choose the noble gas configuration? They chose the noble gas configuration because they believed that noble gases don't react with anybody. So their configuration has to be special. The way the electrons are arranged, the number of electrons that they have is magical. So they realize that every single atom in the world wants to attain that same magic that these noble gases have. So he thought that the other atoms, they form bonds so they can attain this noble gas configuration. Okay, understanding of the electronic configuration of noble gases. Since their theory was based on the electronic concept of atoms, so it is also referred to as the electronic theory of valency. Electronic theory means what? This whole theory is based on transfer and sharing of electrons. Okay, now the main point of this theory are as follows. Lewis pictured the atom in terms of positively charged kernels, the nucleus plus the inner electrons, and the outer shell, which is called the valence shell. The electrons present in this shell are called the valence electrons. What are valence electrons? The outermost electrons, the shell electrons that are present in the outermost shell of an atom are called the valence electrons. For example, the electronic configuration of noble gases. We will start from this. Helium, neon, argon, krypton, xenon, radon. You have to remember the atomic numbers of each and every single of these noble gases to learn how to write the electronic configuration of the other elements. Do you remember me telling you about this when we were studying the electronic configuration in the structure of atom chapter? Right? We use, how do we write the electronic configuration of potassium? We write argon 18 4s1. Calcium will be argon 18 4s2. right? So simply by using this as a jumping point, we can write the electronic configuration. So 2, 10, 18, 36, 54, and 86. These are the electronic configurations. These are the atomic numbers of these atoms. Okay, and this is how the electronic configuration follows: 2, 8, 2, 8, 8, 2, 8, 18, 8, 2, 8, 18, 18, 8, and then 2, 8, 18, 32, 18, 8. Okay, this is the flow of electrons in the various shells of the noble gases. Next, the study. Yeah, the study of electronic configuration of noble gases shows that they have 8 electrons in their outermost orbit, except in case of helium, which has only 2 electrons. Why does helium have only 2 electrons, Drupad? It is a noble gas. Why does helium only have 2 electrons in its outermost shell? Why is it so? It is an s orbital. Yes, yes, exactly. The outermost shell of helium has only one orbital, a 1s orbital, and 1s orbital can only accommodate 2 electrons. Therefore, the electronic configuration of helium is 2. So, the study of the electronic configuration of noble gases shows that they have 8 electrons in their outermost orbit, except in the case of helium, which has 2 electrons. These 8 electrons occupy all the corners of the cube which surround the kernel. This octet of electrons shows a particularly stable electronic arrangement. Lewis postulated that atoms achieve the stability the octet or duplet in the cases of hydrogen, helium, and lithium, etc., when they are joined through chemical bonding. Atoms join together either by the transfer of valence electrons or by the sharing of valence electrons. Now, by the transfer, you get ionic compounds. By the sharing, you get covalent compounds. Okay, so both of them have different routes or journeys. In this process, each atom attains a stable outer electronic configuration. Now, the Lewis symbol. What does the Lewis symbol tell us? The simplest notation to represent the valence electrons of an atom is called the Lewis symbol. These were introduced by an American chemist, G.N. Lewis. In this symbol, the valence electrons are represented by placing dots or crosses around the symbol. Example, the Lewis symbol for the atoms of the second period are lithium. Lithium only has one electron, therefore, one valence electron, you will have one dot. Beryllium has two valence electrons, therefore, two dots. Neon has 8 valence electrons, so therefore, 8 dots. This is how you arrange the dots. Okay, so you can have a maximum of 2 dots on one side. Okay, 2 dots, maximum 2 dots on one side. That is how they arrange the dots. Okay, now significance of the Lewis symbol. The Lewis symbol indicate the number of outermost or valence electrons which help to calculate the common or a group of common valencies of the element. The group valency of elements is generally either equal to the number of dots in the Lewis symbol or 8 minus the number of dots of the valence electrons. Now, for example, in the case of sodium, magnesium, aluminium, the group valency is equal to 1, 2, 3. See, till the number 4, the valency goes from 1 to 3. And we know that after 4, you get 3, 2, 1, and then 0. Okay, this is we have all known about this. It's not something new. So, in case of sodium, magnesium, aluminium, the group valency is equal to the number of dots. That is 1, 2, and 3 respectively. But in the case of sodium, nitrogen, oxygen, fluorine, and neon, it is 3210. To explain chemical bonding, Hossel drew attention to the following fact. In the periodic table, noble gases separate the high electronegativity helium from the highly electropositive alkali metals. The formation of a negative ion from a halogen atom is associated with the gain of an electron, and the formation of a positive ion from an alkali metal is associated with the loss of an electron. So what is happening here? We know that sodium has one electron in its outermost shell. Chlorine has 7 electrons in its outermost shell, right? 1, 2, 3, 4, 5, 6, 7 electrons in its outermost shell. Sodium, what happens to sodium? Sodium basically loses an electron and becomes what? Sodium cation. This electron then goes to chlorine. Chlorine plus one electron becomes Cl minus. Now, you are having a positively charged ion and a negatively charged ion placed next to each other. So, when a positive and a negative charge is placed next to each other, what ends up happening? You get something known as an electrostatic force of attraction. A positive charge and a negative charge attract each other. Okay, a positive charge and a negative charge attract each other, and you get something that is known as an electrostatic bond or an ionic bond. The negative and the positive ions thus obtained achieve stable noble gas electronic configuration. The noble gases, with the exception of helium, which has a doublet of electrons, have a particular stable outer shell configuration of 8 electrons, Ns2 and P6. The negative and the positive ions are bound together by the electrostatic force of attraction. Right, just like a north pole is attracting a south pole, north pole repel each other, but a north pole and a south pole always attract each other. Similarly, a positive charge and a positive charge will repel each other, but a positive charge and a negative charge will always try to attract each other. So the sodium and the chlorine, via the transfer of electrons from the sodium to the chlorine, you are able to achieve an ionic bond. You are able to achieve an ionic bond. Okay, sodium ion plus chlorine ion gives you sodium chloride. Such type of electrostatic forces of attraction result in something known as an electrovalent bond. Okay, so ionic bond or an electrovalent bond. The electrovalence is equal to the number of unit charges on the ions. Magnesium is assigned a positive electrovalence of 2, while chlorine is assigned the negative electrovalence of 1. Now, the above postulate provides a basis to develop the modern concept about the ions formed by electron transfer and the formation of the ionic crystalline compound. Okay, we all know that ionic compounds cannot exist in an isolated form, right? They cannot exist as isolated forms. They always have to exist as a part of a crystal lattice. They can only exist as a part of a crystal lattice. For example, let me take you inside a sodium chloride crystal. So if this is sodium, there will be chlorine, 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 and chlorine. Top will be chlorine and the bottom will be chlorine. Again, when you have a chlorine atom, here will be sodium, 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 and sodium. So every chlorine atom is surrounded by 6 sodium ions, and every sodium atom is surrounded by 6 chlorine atoms. So you get something known as a crystal lattice. That is what we call a crystal lattice. Now, ionic compounds form crystalline lattice. Understood? Did you understand the logic of how an ionic bond forms? Is there any doubts in the formation of an ionic bond? Drupad? Okay. Now, octet rule. According to this rule, atoms of various elements can combine either by the transfer of valence electrons from one atom to the other, either by gaining or losing, or by mutually sharing the valence electrons in order to attain the configuration of 8 electrons in the outermost shell. This is known as the octet rule. Why does 8 matter? The 8 matters because every single atom that is stable has an electronic configuration of 8 in its outermost shell except your helium. This is from where we get the octet rule. So basically, Lewis thought that if an atom is able to attain 8 electron in its outermost shell, then it would also become stable naturally. It will also try to become stable naturally. Understood? That is the idea behind the octet rule. Chemical bond. In 1919, the idea of a stationary cubical arrangement of the octet was abandoned by Langmuir by introducing the term the covalent bond. The bond formed by mutual sharing of electrons between the combining atoms of the same or different elements is called a covalent bond. This bond is generally formed between two electronegative or non-metallic elements. The number of electrons shared by an atom in order to complete its octet is called the covalency of the atom. Okay, the number of atoms that it needs to share is called its covalency. Understood? Formation of chlorine molecule. Okay, so basically, you will never call an ionic compound a molecule. How do you remember this from ninth class? An ionic compound will never be called a molecule. It will be called a crystalline lattice. Or what is it? Huh? You had something known as a molecular mass and something known as a formula unit mass. Both of them are different. Okay. Now, the electronic configuration of chlorine atom is what? 3s2 3p5. It has an electron less than one electron less than the stable noble gas configuration. Okay, chlorine molecule can be formed by sharing of two electrons between the two chlorine atoms. Each chlorine atom contributes one electron to the shared pair so that both chlorine atoms attain the attain the outer shell octet of the nearest noble gas. They have to attain the octet of the nearest noble gas. Understood? Sodium is forming what? So basically, chlorine, when these two chlorine atoms share their electrons, who are they trying to become? Who are they trying to get inspired by? They are trying to become argon, right? They are trying to they are trying to make their electronic configuration to that of argon by sharing an electron. Am I right? Right, Drupad? Yeah. Oxygen has the when oxygen molecule. Yeah, tell me. Oh, okay. Fine. But you're hearing it, right? You're continuously hearing my video. Okay, fine. So, oxygen has how many? It has 6 electrons in its outermost shell. It only needs 2 electrons. And when it bonds with another oxygen atom, it basically uses 2 electrons to overlap with the other oxygen atom, thus forming an oxygen molecule. Okay, that is where you have a double bonded oxygen molecule. That is from where you get the double bonded oxygen molecule. Clear? Now, let's move on. So, chlorine, you have two chlorine atoms. Okay, you have two chlorine atoms. Both of them have how many electrons in their outermost shell? They have 7 electrons in their outermost shell. So, we'll have chlorine and I usually like to draw the cross and the dot for two different atoms so that I can easily see that which atom has which electron. Okay, which electron is being shared by which atom. This is how usually I like to draw. Okay, even though both of them are chlorine atoms, I would make one a dot and other a cross so that I can visualize and see that this electron belongs to this chlorine atom and this electron belongs to this chlorine atom. Both of them are sharing one electron each, therefore they will form one single bond. Clear? Similarly, HCl, hydrogen has one electron in its outermost shell. Chlorine has what? Chlorine has your Chlorine has 7 electrons, so they both decide to share 1 electron. Therefore, hydrogen attains the noble electronic configuration of helium. Chlorine attains the noble electronic configuration of argon. Therefore, they form again a single bond. Carbon tetrachloride. Carbon tetrachloride. Carbon has 4 electrons in its valence shell and chlorine has 7 electrons. So carbon is forming a single bond with each and every single chlorine atom. So carbon forms 4 bonds with 4 chlorine atoms. That's where you get the carbon tetrachloride. Okay, this is what we have for single bond. I know you don't have any doubt in this because we have already learned about these things in the ninth class. So, depending upon the number of electrons, 2, 4, or 6, shared between the two atoms, a covalent bond is called a single, double, or a triple bond, respectively. In a covalent bond, every single bond requires 2 electrons to form. Okay, every single bond. Listen to me, Drupad, this is very, very important. Every single bond requires 2 electrons to form. Now, it depends whether these 2 electrons are part of the same atom or of two different atoms. Okay, if two different atoms are giving one electron each, they're placing one electron in the middle, then they can form a single bond. If they are putting two electrons in the middle, they can form a double bond. If they put three electrons in the middle, they can form a triple bond. Two nitrogen atoms, when they come together, they place 3 electrons in between each other. Therefore, they form a triple bond. A triple bonded nitrogen molecule, a double bonded oxygen molecule, a single bonded chlorine molecule. Clear? So that's how you get the single bond, the double bond, or the triple bond. Each and every single bond, each and every bond represents 2 electrons being shared. 2 electrons are required to make that single bond. Understood? 2 electrons are required, are necessary to make that single bond. Is this topic clear? Drupad, clear? Drupad, are you clear? Okay, fine. Let's move on. So, oxygen has two electrons, so it forms a double bond. Nitrogen has three electrons, so it forms a triple bond. Okay, so what is C2H4? It's an ethene molecule. C2H4 is an ethene molecule. So it can use 2 electrons. It can basically, both the carbon atoms will be sharing two electrons with each other so that it can form a double bonded carbon-carbon bond. Okay, similarly, you have C2H2, an ethyne molecule. An ethyne molecule is formed when three electrons of carbon each are being shared by the two atoms, and one electron is being shared with the hydrogen atom. Therefore, you get an ethyne molecule. We have already learned this. We have already learned about this in the carbon and its compounds chapter, class 10th. Okay, we have learned about this. No, you can remember this. So, what is a single bonded carbon molecule called? What is a single bonded carbon molecule called? It starts with an A. Alkanes. A double bonded carbon molecule is called, and a triple bonded carbon molecule is called alkyne. Okay, alkanes, alkenes, and alkynes. Okay, so Drupad, can you have methane? You cannot have methane because you require two atoms to form a bond, and methane only has one atom. Now, important points. A bond in which the electron pair, that is the lone pair, is donated by one atom but shared by both the atoms is in their octet is called a coordinate bond or a dative bond. Okay, for example, if let us look at the example of oxygen. Okay, so what is happening here? This is oxygen. It is basically forming a bond with another oxygen. Okay, this is what an oxygen molecule looks like. Okay, so oxygen has how many electrons in its valence shell? 6 electrons. Okay, so it used 2 of its electrons to basically form a double bond with this oxygen molecule, oxygen atom. Okay, now there is another oxygen atom who is isolated, who is lonely. So what does this oxygen atom do? It has how many electrons? It has 6 electrons. 2 of them have been used to form a bond with this oxygen atom. There is 2 present here. So what it does is it basically gives 2 of these electrons to this oxygen atom. This oxygen atom has 1, 2, 3, 4, 5, 6. So what is happening here is oxygen is giving off 2 of its electrons to this oxygen atom, thus helping this oxygen atom attain its stability. So these 2 electrons are a part of this oxygen atom as well as this oxygen atom. So did this oxygen atom contribute anything to form the bond? No, it didn't. It only accepted the shared pair of electrons from this oxygen atom, and this molecule is what we called ozone. This is called the ozone molecule, the molecule that is protecting us from the harmful ultraviolet radiations that are coming to us from space. Okay, this is the ozone molecule. Okay, clear? So this is what a coordinate bond looks like. What? Okay, so okay, fine. We will continue this chapter in the next class. I hope you really understood my video. Okay, let's just do the revisions and I'll meet you in the next class. Okay, if you like the video, please do like, share, and subscribe, and I'll see you in the next class. Thank you.